project life expectancy. The data set was gathered from the World Health Organization and put it together by Dikesh, Russell, and Duan Wang. It's a tabular data containing 22 columns and almost 2,000 rows about 193 countries, containing 3 categorical features and 19 numerical features that we will go through the project. The main goal of the project is to predict what are the main keys that positively influence the life expectancy in the countries covered by the data. That will help to understand the actions that can be taken to increase longevity in the countries that have low life expectancy. The data cleaning was something that basically I dropped the known values and around some of the zero values to the mean of those columns. Further in the project, I decided to go back to the zero values because the data was getting numbers too high after I round to the mean. Exploratory data analysis. The main exploratory analysis that I saw was in the heat map. You can see the negative correlation that life expectancy and other data has, and also the positive ones here. This one is the total mortality, and the other two ones are income composition of resources and schooling. That means some of those might be the strong correlation with the life expectancy, but need further analysis. CDF and PDF of life expectancy and total expenditure. You can see total expenditure has dots in a large variance that means that that might not have a strong correlation with life expectancy, but you can see that by the CDF and PDF that the data has a normal distribution. Life expectancy by income of resources. You can see here that the median and the mean are close values, so that suggests that the data it's balanced and doesn't have that many outliers, so the median and the mean end up being close by number. Here's the same for income composition of resources. Median and the mean are very close. You can see that the largest quartile here is the majority of the countries have a lower life expectancy and also a lower income. Linear regression, that was my first approach of linear regression. You can see here the values and the coefficient for income. But the interesting here is the plot that you can see that how the data is distributed and it follows the line, so that means that might have a strong correlation with life expectancy, but still need further analysis. This is one of the main sites that I had in the beginning. Here's a volume plot of the developed countries and the developing countries. You can see here the strong attributes that have negative correlation with life expectancy, like adult mortality and infant mortality, that would be around here, and even thinness, they doesn't exist here. It's a very low number and significant for the developed countries. So wherever developed countries are doing its work, like providing schooling, food for schools, and vaccinations, etc., is definitely helping to increase, and of course many other variants. Schooling versus life expectancy. Here you can see that they have some distribution, but here the data is very spread out, so that shows that they have a correlation, but it's not that strong as life expectancy versus income composition of resource, or even schooling and life expectancy. Here's a box plot. You can see the majority of the countries here are on the low end of life expectancy and just a few in the high end. The same for income composition of resources, but the top quartile is a little larger. The schooling and you can see that both quartiles are kind of similar, but you also can see that the whiskers here, a lot of countries have a really high education and a lot of have very little education. Through this scatter plot, I attempt doing that with very different attributes, and the best result that I got was income versus schooling life expectancy. You can see the distribution of the data here, how linear it is, and how it increases income, schooling, and life expectancy goes together. Pair plot. Here you can see the pair plot for income composition, schooling, life expectancy, total expenditure. Here's total expenditure. You can see that has almost no correlation. There is no correlation actually with none of the data. Here's income with the schooling. You can see that they have a strong correlation. And here income with life expectancy. Here you can see better life expectancy, income, and schooling. Multilinear regression, that was my first model to try to predict life expectancy. I ran the data for every single model, ran for all the numerical features excluding categorical ones, and after that I filtered to life expectancy and income composition of resources. So let's check that out. Here the numbers are very similar to the heat map. The numbers are different, but the correlations are similar. Here's the income being one of the largest values. Here's the schooling, and here's infant death, and also under 5 death and thinness. There are the strongest correlation with the data, negative and positive. And thinness, death is something that's predicted that can affect life expectancy, but how do we change that? So then we go back to the track of income composition of resources and schooling. And here shows total expenditure, but we already ruled that one out. Here's the multilinear regression for life expectancy income. You can see the mean error is higher now that the data is filtered, but that's is expected as I'm aware that the data is correlated to other attributes as well. So that means the square error should be larger if the data has other correlations. Here's income, a very high number compared to the schooling. Data comparison of the filter attributes and the attributes. Here's the error. Filter has a higher error, and also they have a higher number for income composition of resources. Schooling just a little bit above. Multilinear for the interactions. Here I did the interaction. That was my first negative feedback. The R square is low, the income is bad, and the P is also large value that suggests that income might not have a strong correlation. Then here I plot the leverage versus curve residual using P greater than 0.05. Here we can see a lot of noise in the data and outliers. So the idea is to gather this and clean the data and the imbalance in the data and see what result we can get that running multilinear regression again. Here you can see many drops, many values were dropped from income and schooling. And here's the final regression model with the data trained and clean. Now we can see that there is a very strong R squared, and also the coefficient increased a lot of income composition, also schooling, and the interaction among both then are quite strong in this data. That suggests that income composition has a strong relationship with life expectancy, and schooling comes in second, really far behind from income. Comparison of initial regression and regression model. Here are the comparison, the data before cleaning, filter, and manipulated. Second model that I chose was the KNN. The 50 here has a mean square error, but I decided not to go further because this first number was already not good, and then the KNN is also a more simplistic model, so I decided to try to find another model that would fit good the data. And then I went to the decision tree regressor model that's not covered in class. I did the same thing. I ran a schooling, life expectancy, income, and after that I did for all the attributes. Here you can see the mean square error are read better than the KNN, even for the filter data. Here the income has a lower number and schooling also a lower number. The most interesting about this is this plot. You can see that here has a lot of noise, outliers in the data, but around 68 here and above, you can observe that the data is predicting very good this range of the life expectancy. And this suggests that this model is a good approach for what we are trying to find, which is how to get the countries to have this result, which is a high life expectancy. The decision tree for our attributes, you can see the error is very low, and that's by far the best values, and it comes to a good number here, 15%. And you can see here the data is better distributed and still has some outliers, but the data here gets together in the end, and also above around 68. So it's a good data. It's a good model that predicts very well the complexity of the data. Resultant analysis. Here are the models for the decision tree model in green and the other ones that we already covered. Here's the initial model and the final model of multilinear regression compared, and the difference between them. You can see the increase of the income composition of resources. The difficulties that I faced in this project were basically how to manipulate the data, what attributes I'm seeing. I had to return the zero values that I had round to the mean and go back to the raw data, and was also difficult to analyzing all the numbers and values and figure out which one was correct and which one could be biased. So my conclusion after the analysis was that income composition, resource, and schooling are showed significant positive correlations with life expectancy, and the categorical factor status play a crucial role for understanding the data and the countries that have life expectancy. My conclusion is the multilinear regression model and the decision tree regressor model were both a good fit, being the decision model a better fit because since the beginning with the raw data, the decision tree regressor model already showed good values for the error and also for the income and for the schooling. While the multilinear regression showed better values when the data was manipulated. So a way to improve this project would be going through further analysis and manipulating data, cleaning the data for the decision tree regressor model. The K-NN model was not a good approach because it was a simplistic model and also was not a good fit for the complex correlation of the features. So the conclusion is that the project fulfilled its purpose, that was to find a positive correlation values of life income, life composition of resources, which is income and schooling.